So we're coming close to our content program today. And so what we're going to do tonight right now is that with the panel we've got together, we're going to have three different distinct lenses on for the same challenge that we are facing, which is building the AI-ready data center. So joining me today, Samuel Prikumar, Manager of Strategic Growth and Operations for Europe Services at Rosen. And Giuseppe Forgone, Sales Director for Regional Strategic Accounts in Northern Europe at Vertiv. So, gentlemen, welcome. We've heard the change, but what I want to do today is asking what is actually changing on the ground? What are the real operators, what they say they want actually ready to be executed today? So if I could have Giuseppe, if you could start for me, please.
Yeah, I mean, obviously what we're doing in terms of building data centers at the moment is we're moving at incredible pace. So you've seen a lot of talk today about time to token, about speed to deployment, and that is the biggest challenge that we've got. My colleague Ivan did a great presentation. But getting to a shovel-ready design is the biggest challenge that we face right now, alongside obviously getting hold of the necessary power.
Perfect. Samuel, if I can have your thoughts.
Well, from a strategic or from a service perspective, it's about having the right people there. In terms of methodology with project management, you have to go very in depth. You have to be able to orchestrate your ecosystem in a way that you can be on time for these projects, because often there are delays and then suddenly everything has to happen immediate. So the time for preparation has to be utilized very, very well in terms of actually then being effective in deployment. That's one of the things, the big takeaways in deploying for these AI clusters, besides what the client's expectations are and what the thresholds are on service level agreements and so on.
Perfect. Jonathan.
Yeah, I think from my side of it, I mean, a lot of the work I'm doing is working with investors at early stage and sort of early stage developers new to the market, and that's trying to understand what AI infrastructure and power requirements they're going to be looking to need and to how to validate those from an early stage feasibility. I think the big shift we are seeing, I think it's been hit on quite a lot today, is looking at the power, looking at the availability, but also I think we're seeing an awful lot of sites where they are saying they are AI ready. And I think the big thing I'm trying to explain from my side is also it's understanding is what actually that AI ready model actually looks like. There's different challenges within that. So is it GPU as a service? Is it training? Is it inference? Is it sovereign? Is it enterprise, etc.? All of those are slightly different asks. So that's a key thing to also to ascertain as we're seeing some of those big shifts coming through, is actually what does that look like? So you're then deploying the right technology, the right solutions, the right for the investors across the board, really. So it's looking at that in a far more solid piece. So yeah, sorry.
Perfect. So I'm just going to start with Giuseppe again. Sorry about that. So we've spoken a lot about, so let's say, Vertiv's modular and AI-ready solutions when we had the previous discussions. So when a client approaches you for an AI retrofit, what is the most common piece of legacy infrastructure that they realize is a total deal breaker for their plans?
I think in terms of retrofitting an existing facility, I think the challenge is around having the space for the equipment that's required. I think one of the things that Ivan mentioned on his presentation earlier is that when you had a 100 megawatt data center, you needed a certain number of chillers, or you needed a certain amount of UPS systems. What we've got now is a huge compaction of the white space, a requirement to have all of those pieces of equipment or the compute in a much smaller space, but an enormous change in the requirement for the infrastructure that surrounds it. So when you look at an existing facility, the challenge is how do you get that additional power for the cooling? How do you get the additional power for the compute? And how do you fit that into an existing design? And because of the different variations in design that we've seen over the years for data centers, some are air cooled, some have water cooling, some use perimeter cooling. It means that every use case or every change in use of those data centers is unique and has a specific requirement for design.
Perfect. Jonathan, I'm going to move on to you now. So for a project management and cost consultancy standpoint, specifically at Economic Leads, are you seeing AI projects being held up by more of a sticker shock at the required investments for the price, or by the sheer complexity of the integration of these highly dense liquid systems into the existing sites?
That's a good question. I think because of the model is completely different from GPU as a service, and the commercials and costings that are coming out of an AI, I think that is very much more understood. And the fact that the technology and deployment strategy that goes into them is understood a lot earlier as well. So NVIDIA have done a great work in the background of this, looking at the AI-ready infrastructure, some of the designs. We're seeing that obviously with what Vertiv are trying to do to employ into their sites and their solutions as well. It's getting that piece. So I think that is becoming far more understood. I think obviously the key complexities from a cost and program management though is how we tie this all together. And it's looking at those key deliverables of actually when the site is. So it's looking at those long lead times. It's looking at those key points that are normally outside of their control a little bit about how we manage the program. But what's interesting is where we're seeing more localized or smaller sites that are able to accelerate and develop that, and looking at containerization or looking at retrofits where the power's there, we're able to look at it far more objectively. And I think the PCE stuff that Paul was just going through is a great example of that as well, whereby effectively by looking at those with those companies and to see what we can change around or filter into that, it gives us again greater ability to look at the program more objectively, and then to feed that back. But the key thing here though is just having that open dialogue and those conversations up and down, from the program, the cost, to the investors, to the delivery teams, to the suppliers, etc., so that we're all joined up on the same hymn sheet to make sure it works correctly. That means the project is likely to then hopefully avoid a lot of the bumps in the road that we do see. But we are seeing this coming through. I mean, I've been speaking to developers recently whereby they've jumped from GB300s and they're now looking at the Rubins coming through for the UK market for end of next year. That's a huge different design capabilities they're having to adjust for. And that's one of the conversations we're starting to have now. So it's looking at how do we future-proof or bridge those gaps coming into it so that those sites, when they go live, aren't going to be needing a retrofit straight away. So we're planning that into those types of conversations. So it's very, very interesting, but that's where we're trying to be strategic, but also utilize our knowledge and support from what we're doing from a program, from cost, to help drive those conversations earlier where we can do to help make those improvements.
Perfect. And now, Sam, I've got another question for yourself. So AI obviously isn't just about power and cooling. It's a massive data throughput. So how are you seeing the connectivity layer being redesigned to keep up with these new clusters? And are operators underestimating the operational burden of managing this denser cabling? And obviously anyone else can interject as well after Samuel.
Definitely. It is heavily underestimated and heavily understaffed. We can see this now because it's not even going, even pre-AI, I mean, if you're not talking about a specific use case for a data center, the connectivity, even if you look on it in terms of regions, no. It's something where we are now having approaches, conversations, and even to a certain extent, consulting engagements where we are having these discussions, how to fit out, how to account for capacity, how to look at a point of presentation or a meet-me room not as only a cost factor, but as a strategic asset, meaning how do you actually utilize the fiber? How much more fiber will you need in the future? Because the requirements on what inference entails, what this means in terms of bringing data from A to B is a different ballgame. And these requirements are only going up. And it's a huge cost factor, of course. Just very practically, just opening up the roads, laying the fiber, making sure you have enough and account for that future capability is something which is not factored in enough yet, especially not coherently in terms of having even a geostrategical approach. Like in Europe, it's just a different discussion on AI, and you have to find those pockets, how to address connectivity specifically and coherently down the road in terms of addressing what your use case is for AI, but also data center colocation, all of these segments. So there are a lot of things to be done if you have to do it correctly, because you can use these pockets that you have between permit delays and all of that to actually address these questions. Do your due diligence on that aspect and actually flip the thing from a threat into an opportunity for operators to utilize connectivity in a more commercial and a better way for their business model entirely.
Perfect. Appreciate it. Thank you. We've got one audience question as well. It's for you, Jonathan. So there's two questions within it, I believe, but I'll just ask the first one. So lead times for high voltage grid connectors are now stretching 6 to 8 years in some of these regions. Are you seeing project managers pivot towards the on-site gas-fired generation or SMRs as the bridge to get the sites live by 2027? And because we want them to be up as soon as possible, of course.
This is a really cool question, and the key thing is they're exactly right. We are seeing the dates pushing back from the power a little bit. This is why we've got sites that are now looking at interim solutions to trying to bridge those gaps. We're now looking at how those can be phased, deliverables can be sort of accounted for that, and where we then can look to see, can we look to accelerate on any of those local DNO and IDNO sort of like conversations to see if we can bridge those gaps. But the key crux of this, though, is looking at those interim solutions, is seeing what we can look to do to bridge. Gas is a brilliant one. It hasn't got the same challenges that we're seeing in the terms of deliverables. So it is quicker to market. It is cheaper than the electrical grid. It is more available. There is obviously a trade-off, though, the size of the generators and the gen sets you're then looking to provide. Unfortunately, I wish they were smaller. They're not. SMRs is a brilliant solution.
I agree.
The crux of that, though, is that we have to work very, very closely with the nuclear bodies and the nuclear regulatory bodies. So it's not a case of, unfortunately, waving a magic wand. It's a case of us trying to find the sites and also working within the national infrastructure, be it either from the UK or whatever countries are doing it. There has been a lot of reticence around certain parts of Europe on this as well. But it's working together collaboratively where those sites can stack up and make sense. And it's whether or not, though, this is the interesting part. So if you're looking at a neo cloud or a hyperscaler that is looking at that power and availability, and they're happy to say, look, this will happen in 7 years' time, but it then gives us a guarantee of X 100 megawatts or gigawatts of power, for example, does that then unlock the doors from a financial perspective to make it reality? But the key thing is, though, is then still understanding what's the interim bridging or gap solution to that site, which still gives us the meaningful power that is consistent 24/7. And unfortunately, we have to look at the lowest denominator for that power as that starting point and going forward. So we could start off with 8 megawatts for a site that could be 500 megawatts, but we have to start off with that lowest denominator, unfortunately, at the start. So yeah.
Perfect. Any thoughts, Giuseppe?
I think it's interesting because I think that the use of gas generation is probably a shorter term solution to a grid constraint or availability problem that can be resolved. If you're looking at a small or an SMR, that's probably a permanent solution for that site. In reality, I think we're talking about two different things. Gas generation, I think, is being used quite heavily in the US in terms of actually permanently powering some of these facilities. But I can't see the regulatory environment in the European space accepting that in the longer term.
There was one example, I think, in the US, but I think they're using like rocket fuel, aren't they, to do jet fighter stuff to power it.
Yes.
So yeah, I think it just shows the fact that we've got to think a little bit outside the box and continue to do so for these sites. So yeah.
Perfect. And the second question that the person asked is, it's from a cost standpoint, how much of the project's budget is now being consumed by the liquid cooling infrastructure compared to what it was 3 years ago? And the are we seeing the fundamental shift in where the capital is being spent?
So this is a tricky conversation. So essentially, it depends on the solution. So it depends entirely on what you're looking to build out. So from a cost perspective, if you're going through from what was an air to direct-to-chip solution with in-row and rear door, and the cooling loops that are now attached to that, the cost is increasing. If you're then looking at it from an immersive, or you're then looking at a dielectric fluid type of solutions, again, the cost changes. So the problem is it depends entirely on the design and the density of what you're trying to achieve to run through to, which has a big knock-on effect of what you're trying to achieve. Also, it also depends on what type of power or megawatts you're looking to run here. So you could have an AI pod which consumes 1 megawatt of power, which overall the solution is going to be quite small, as we were talking about earlier, where we're shrinking it. But the grey space architecture, the background for that flow rates, and even if we do the high delta T's that Paul was looking at earlier, to give us that efficiency, we still need to take that on board. And there's a few, that is starting to become known. It does reduce the overall cost of the infrastructure slightly, just due to the density and how the size of what you're looking to do. But unfortunately, this is why I do feasibility studies and support, to provide that so we can then do proper costing elements, because it's a bit like asking for how long is a rope on a piece of string. I can't give you the exact answer. I wish I could.
Of course.
Perhaps Giuseppe from Vertiv might be able to give us a containerized solution cost benchmark between all of the models to see what's different. But again, it's a tricky one to ascertain, because it comes down to so many dependables. So again, also, if you're going from an H100, H200, a GB to a Rubin, you're then looking at the Rubin Vera. And if you're then looking at going ahead in the next couple of years, the Feynman, all of those are going to require completely different solutions of cooling infrastructure again. So where do you want to map it against in that regard?
Yeah, I think the other thing that we should think about is, if we look at traditional cooling, if you were in the perimeter space, you'd need a chiller, you'd need the pumps, you'd need the pipework, you'd need a terminal unit. When you're now going to direct-to-chip solutions, you're effectively adding into that chain the secondary fluid network. So in reality, in order to deliver that cooling from the chiller to the chip, there is more infrastructure that's needed between those two devices. And so therefore, the amount of cost associated with it will go up slightly. And what we do is we try and work on solutions that either give standard designs and standard answers to that question, which will then allow us to potentially reduce the cost. But there is, because there's physically more infrastructure, there is more cost.
Perfect. Sam, I'm just going to jump back to you for this question. So we go from the audience as well. So for fiber cables being demonstrated with over 13,000 individual fibers, this level of density, is the physical cable management itself becoming a bottleneck for AI deployment compared to the actual hardware itself?
No, the physical cable management is not a bottleneck. It's more about planning and accounting for it. In terms of, no, physically, I wouldn't say. Just to give you an example, it's more about planning. We have a use case where we have managed point to point 2,000 to 12,000 connections. It's about having the right cable plan in place. Then follow up for operations is to have your appropriate tooling to manage it. Physically, you have to then account, of course, in the fiber trays, etc. But till now, I haven't seen that bottleneck yet. Because mainly the cabling will be on the spine and leaf architecture, not as dense on the end devices. In my opinion and experience, what I've seen on the floor with these machines, it needs a bit more of planning, yes, for sure. But it's not a bottleneck. And the manufacturers, and I come now with my company from a manufacturing background, we don't have those bottlenecks yet in terms of providing connectivity or connectors and technology for the bandwidth or even physically. That's why we moved to fiber, right, from copper. So I don't see that bandwidth yet. And now even with technologies like on cabling, like hollow core fibers now. I don't see that happening.
Perfect. Any more thoughts for either of you two?
I think it's just a growing network. You can't constantly
It's
looking at, for
completely-
me. Yeah, you never quite know. I think we're seeing quite a lot of NVIDIA investing into photonics going forward as well to help on this type of channel. And I think that's what Sam was just talking about from Hollow. So yeah, it's a case of, yeah, I think it's just a growing thing that I think, thankfully, we've got people like Sam who are keeping up to speed, up to pace with it to help us out and to manage that through for us. So I don't have to overthink that bit. So yeah.
Perfect. I'm just going to go finish up this question as well. So the AI training required, it needs constant communication between thousands of GPUs, as we see today. Are you seeing the operators move away from the traditional structured cabling in favor of more flexible, modular bus style connectivity, just to avoid it being locked into today's rack layouts? This is for Samuel on being asked to.
Well, it's becoming, well, we are pushing more towards it because in terms of having these conversations, because till now, a cable is a commodity. So it's for us, to prove that value that you have to think the whole chain through and actually have it in place. But then, of course, you have NVIDIA who's doing, who has their reference architectures and they have the cabling in place basically and accounted for on these very highly scalable solutions up into the the huge clusters, no matter how many machines these clusters entail. So in terms of, yes, it's always a matter then how your use case looks, how you want to scale your hardware, but then generally speaking, the big suppliers or manufacturers have it generally accounted for. It's then only a matter of how you operationalize it during the transformation phase. So at some point you have to sit down and talk about cabling. It's not a very popular discussion. It's very unsexy, but in terms to speed of
But it's very
deployment,
necessary, no matter how
always
unsexy it may
been
be.
a part of conversation, much before AI, much before even AI. Cabling and the homework that it entails has always been a elementary, vital part of any discussion in deployment. So it just scales a bit more. That's
Giuseppe,
my answer.
I'm going to go back to you. Oh, apologies. Yeah, I'm just going to jump back to you, Giuseppe, from the Vertiv perspective. So with the shift towards the high density, quote unquote, we are seeing the move from standard racks to highly specialized setups. So are you finding it from your side that operators are moving away from more customized one-off builds and more in favor of the standardized modular units just to keep up with the deployment speed that AI requires?
Well, I think speed of deployment being the key. If you can use something that's previously been designed, previously been proven to work, then you can reduce the amount of time you need to complete that design work and therefore get that into production and then to sites. So we are seeing a lot of moves towards standardizing a design. You'll have seen things that come out from NVIDIA in terms of their particular rack designs and their pod designs. We've got our own designs that we publish that people can see and we talk to our customers about. And absolutely, one of the key messages is if you go for something bespoke, it's going to take longer to deliver.
Perfect.
And I'm sure everyone here would agree with that.
Yeah, I wouldn't think we'd disagree with that. But by all means, you're more than welcome to disagree, but I don't think so. I think I've got one question actually here for the whole panel, so that's good. So for the ROI of sustainability, which is a very good point to raise. In 2026, the heat reused for district heating finally became a genuine revenue stream for operators. Is this still a primary concern, or is this just an ESG compliance box that's just a bit more difficult to monetize?
If I start off on this one, then it comes down to a couple of key factors on this one. So yes, it is a key deliverable. Yes, it is possible. The key factor comes down to the site's location and the ESG and permitting factors that then come into that, and also whether or not there is a viable offtake for that heat to be utilised or a network to support it. A lot of the projects we're looking at going forward, we have to see whereby there is either a council or industry or another local body nearby that is looking to also build out that infrastructure and look to take their heat off if it's not already clear what it's going to look like. We do see a number of sites whereby we're building that requirements there, and sometimes it's never utilised or not being utilised at the moment. So it is something that's moving ahead. It is something we're seeing that has been driven out very hard from the EU and is now being put into effect across the UK. The key thing we need to bear in mind, though, is that the heat district network to support this as we move forward also needs to have investment and development done to that as well as part of those programs. So it's not, unfortunately, a data center fix-all solution. It's a case of we can provide that heat, we can provide that from the power and the cooling infrastructure we've got coming through. AI supports that. AI gives us much more viable heat to be consumed and to be passed through. And also gives us greater cost efficiencies as well from a cooling loop structure. But the key thing is it has to be taken. If it's not being taken, we can't do anything with it. So it's a case of we then need to put that infrastructure back into place with CRAHs and chillers and everything else just to get it back down to the required delta T that we need to have. So it is there. I think we're going to see more of that moving forward, and more financial models looking to capitalize on that from a data center as well. The crux of it, though, is unfortunately will always come down to the sites of where this is possible to be done, and if it's not possible, unfortunately computer says no. So yeah, from my side. Yeah.
So I mean, from my point of view, AI does bring a great opportunity on that. We saw Paul talking about delta T. We know that we get a higher grade of heat back from the direct to chip cooling solutions. We might, and therefore to reuse that heat, we don't need to use as many heat pumps. We don't need to spend as much money upgrading that heat so that it can be used in a process. I really like this as a subject. I think if we look at the possibilities for vertical farming, for growing flowers, for other industrial processes, for there's almost untold uses. However, we need a really joined up approach to that, probably from a governmental level, in order to deliver that as an actual usable thing in this environment. So in terms of the technology, in terms of being able to put a heat exchanger into the system, being able to put heat pumps into the system, we're already there. We can do it. But to Jonathan's point, there has to be something there that will use this heat. Otherwise, that facility will just sit idle.
You need industrial collaboration, effectively. That's the most important thing.
Exactly.
Perfect. Samuel?
Yeah, I agree with Jonathan and Giuseppe. I've seen one or two interesting use cases in Vienna. We have Digital Reality who does it. We also have another client. Maybe you've heard of the product Yexio. So that's a fully sustainable data center built in wood. And what they do is they have communal reuse. So they don't have big data centers. This is nowhere close to AI. It's about 5 megawatts. But what they do is they do reheat. They embed their data centers outside of hotspots, data center hotspots, and then there's a communal approach to it to heat reuse. And to talk to another point from a service perspective, and this is something which was very surprising over the last year, is even suppliers it's a chance, because of course you are tied in and into providing data for ESG compliance, which makes you, and this is a chance for suppliers. If you digitize your processes, you can add value to your services, because you effectively provide data points and compliance towards ESG criteria of your clients. And in fact, there are bit and selection of vendors which are now much more going towards ESG criteria if you can provide these data points and this compliance. So there were a lot of bids. Of course, it's sometimes purely commercial and pricing, but then we have experienced that there is focus on ESG compliance, and that was for us a bit of a surprise. We can do it, of course, but then how it impacts the value of what your service is to your client is a totally different opportunity and chance on the market if you do it correctly, if you understand what your processes are, and how you can actually thrive in this environment, in this regulated environment, providing these data points and this compliance to your clients. And that's something which was a big takeaway last year in bidding for services to provide for clients.
Perfect. Jonathan, I'm going to go back to you. I'm just whittling through the Q&A questions. So supply chain. So we know it's been a bottleneck for years. Of course, we all know this. Everyone's rushing towards AI, and we are seeing that the shift where project managers now are prioritizing pre-orders as critical infrastructure before a design's even finalized, just to secure a spot in the queue. Is this the right approach? I don't know. I don't think so. But tell me your thoughts, please.
No, I get it. There's a couple of things. So we're seeing loads and loads of sites saying they're AI ready. The reason for that is they want to go to market commercially to make them viable as quickly as possible, so they can either secure their end user tenants or they can secure their funding for them going forward. The criticality part is obviously once they've got that base level design and they then speak to the suppliers and they find out there's a 48-month or a 48-week lead time for some of these key items. Normally in the transformer space, electrical space of it, unfortunately, that is where the key cruxes are. If those long lead items are where the electrical systems are, the risk for that is mitigated. Where they are, for example, for obviously a containerized solution for Vertiv, there's always going to be challenges within that to understand. The key thing is though, is if you've got a bit of materials and you understand what you're looking to do, and that can either be slightly interchangeable or you know it's going to be coming later on, or you can phase that build out. I think there's a really good strategy to be had there. And I do think actually if you're looking at a phase build and you can start, but you can then look to juggle that a little bit from the background from a program perspective, it might give you some flexibility. The key thing is just to understand what is that phase one deliverable looking to be and what's the phase 2, phase 3, phase 4. If we can mitigate some of those risks going forward, then placing those orders earlier, I think is a good strategy to have. But it really comes down to is actually where those key pressure points are. And we do see it quite a lot, unfortunately, but it's a case of where you've got that commercial go live dates to hit those targets and to be ready. If you've been shown to place those orders wrong, unfortunately, it's a chicken and egg scenario whereby you need to be placing those orders, unfortunately, regardless, to get them on there and just then having a conversation later on if you need to then change the scope or change it, you have it and then look to work with those suppliers and that supply chain. So again, that's the crux of it, unfortunately. It's a bit of the chicken and the egg whereby the dates to go live, the targets for the site to be that is driving a lot of those conversations and that pre-ordering. And yeah, it's not a case of we can wave a magic wand, but it's a case of looking at it from a program perspective of how we can be the most effective within that program to make sure we mitigate those risks as much as possible and working with key suppliers on that. For example, Vertiv, great example. We can then work with them, hopefully understanding where we can look to mitigate that. Can we push something out? Can we bring something in earlier, etc. But it's having those relationships to have those conversations. So yeah.
Okay. Do you have any more supportive arguments towards it? What Jonathan's just raised?
Yeah, absolutely. I mean, we are seeing a lot of lead times increasing in terms of the supply of the components for an AI deployment. If you order early, if we identify long lead items, if we use, back to where I was earlier, a standard design or a standard approach, then it makes it easier to pre-procure some of those longer lead items to secure that deployment time.
Perfect. I'm just going to work through this question I've received as well. So, Jonathan, this is aimed again towards you. So it's regarding risk management. So what are the bigger risks that you're seeing Gleed specifically facing? Is it building a facility that is under spec or and quickly becoming obsolete? Or is it becoming over spec for a facility its size that is AI demanding, but it's not fully materialized yet because it hasn't got that specific client yet?
Oh, crikey. Yeah, from the risk perspective, you're trying to, it's a very fine line you're trying to balance here. So essentially what you're trying to do is slightly over provision for the site to mitigate the risk from the power perspective. And what I will break this down first is probably into where those risks can come through from. If you look for a power first strategy, and I think from the area workloads, that will then work in your favor. essentially, if you don't take all that power, but you have built out the infrastructure later on, it then mitigates that risk for year 3, 5, and 7, when you're looking to that. If you don't have an end user starting off with, though, I think there is a challenge to that. I think what I'm seeing, though, is with the neocloud operator and the GPU as a service, they're actually pre-selling the GPU and compute with the idea of that coming on board within the next 12, 18, 36 months. So a lot of that risk then starts to become mitigated. Where we're seeing that historically from a hyperscale perspective or other clients that are building out big sites, again, it has they obviously need to make sure that they are securing that power first for those sites to be built out. They're looking at, again, what that interim solution is. There's always going to be some risk that they could open provision for those sites, but effectively, if they have slightly over provisioned, it just means they're better off later on down the line. But it's the key thing, obviously, is those end user demands. If you've got an end user and you've over provisioned something to be a neo cloud, you've ended up with an enterprise cloud who's utilizing X percentage less. Yeah, it's a case of, is that a sales function that's gone slightly adrift and awry on that perspective for that, or are you then looking to then change the design or change the infrastructure to then look to mitigate those risks and those strategies earlier on? So again, it just comes down to understanding, but this is whereby we need to be far more joined up, having this conversation that I have with like feasibility, looking at the strategy for the site, looking at the potential end users. If you're going to be putting out AI, it's going to be for GPU as a service or training and inference, having a really good understanding of what servers they're looking to procure and to acquire, what the cooling element is going to be. Looking at, again, is when those from the power on date's going to be, and then you can start mitigating all those risks. But the key thing is to break it down, unfortunately, into small chunks, is looking at those risks, breaking it down so that you're then effectively mitigating that as much as possible for those financial solutions, unfortunately, because the financial backers are going to be wanting to see what is the mitigating strategy, what's options A, B, C, or D, if needed, to deploy for those sites. And then it's looking at how we work those coming across. But it's just trying to be very much aware of modular, scalable, and just thinking about the investors, unfortunately, to give them the confidence they need to have. So, yeah. Does that help?
It does help a bit for me, at least. I hopefully it does help the audience as well. We got one question from via email, so this is for the whole panel. So AI chips have served a much shorter lifespan than traditional servers, something only around 2 to 3 years before they are swapped out. Are we designing data centers that are flexible enough to handle the total tech refresh every 36 months without shutting down the entire facility? That's a good question. Samuel, can I get you to start, please?
I'd say no, because it's just the life cycles are different from the chips to how you construct and how you build core and facility. No, it's non-linear to what traditional workloads are. It's this, and that's what also is fueling this growth. These chip cycles. So not, to my knowledge, not yet. It's a matter of then going back. I won't say redesigning everything, but you have to look at it with every iteration cycle of chips, what customizations or what redesigns you have to do in terms of cooling and power and everything, because of the requirements that these new chips have. So I'd say just on top of my head, no, not at that scale. Maybe I'm wrong.
Sure. Giuseppe?
It's a really good question. I think that the challenge we've got is if we look at the pathway of development across the next, if you're building today, for example, and then you're expecting to have a total refresh in 4 years, we already know that from a technological point of view, the compute is going to look completely different, in terms of the approach. And what we're also seeing is, we obviously develop products to serve this market on a continuous basis. We're almost at the point where we're launching and then we're moving again, and the product's obsolete by the point that you've got that to market. So can we design a data center that will support being re-provisioned after 3 years and won't need any significant modification to the infrastructure? I think the answer is probably no. Can we get to the point where we can make and design products that will support that re-provisioning? Absolutely. I think that's something that's going to be coming over the next few years while we see the life cycle of these facilities drain down.
Jonathan?
Yeah, I was just thinking this through. I think both just Giuseppe and Sam have been great points on this one. I think the key thing though for these sites is the key strategy in the back of the behind the scenes needs to be first on the power and availability. So you've got that flex. So unfortunately, back to my previous question and answer on that one a little bit. But what I would say though is looking ahead and moving with the speed we're looking at, and you look at the NVIDIA roadmaps, it's how do we provision that? And I think the key thing is to look at, from my side, is looking at, okay, if you're looking at sites going to go live in 5, 10, well, going live in like 2-3 years and going to be having a 5, 10, 15-year roadmap, what is the clients looking to do with it? Yes, the chips could go out of date. Yes, the chips could decrease and you go from a rack space of an AI pod of, let's say, 20 down to 5, still utilizing the same power, still might have the same gray space infrastructure for the liquid cooling, still might have the same flow rates, but obviously a faster flow rates because it's more densely populated from that pod perspective. It all comes into what the key aspects are going to be from the clients and what they're driving out. We are being dominated a little bit by NVIDIA. We've also got Elon with his chips being developed as well. AMD are also coming back to the marketplace with their chips. I think Intel obviously is still working that through now, working in collaboration, hence the Rubin Vera, where obviously the Vera side of it is the CPU side of it as well. I think we just need to sort of like pause a little bit and just make sure essentially in that timeline, what we're looking at, I think we're going to see greater efficiencies being made within the chips that are coming to market. Because yes, we can have an AI pod running at over 1 megawatt, fantastic. But what does that actually mean for the rest of it? So do we go from one hall down to one rack? Yes, that's possible, but as long as it's financially still viable as well. So this is the key thing, it's understanding it from the investor structure, what needs to be done. Because it might then be that we drop containerized pods or look at more flexible solutions so that we can adapt and we give us that flexibility coming into the design and to the build as well. So perhaps it's slightly looking at it from a different angle whereby we are adding onto the site flexibly with a containerized solution that companies are coming up with now. So rather than just having one dedicated build, we've then got one containerized as well. I don't know. It's a really I don't know. I needed my crystal ball out on this one. I'm not quite sure where it's going to be. So yeah.
Completely understandable. Just cognizant of the time, I'm going to ask one final question. Sorry if I didn't answer any question in the chat. So, final thought basically is regarding AI. Is it going to make the data center industry more sustainable because it forces us to innovate, or is it going to simply break the grid before we get a chance to fix it? Would you like to start, Giuseppe?
It is going to force us to be more sustainable. I think at the end of the day, we started off this call talking about gas generation, talking about SMRs, and I think that how we power and therefore reuse and use that power within those environments is going to be crucial going forward, right? We need AI to have a good public perception in terms of its doing good for the world, helping with research, improving people's lives, and it can only do that if that energy isn't breaking the grid, isn't causing people to have power outages, and so absolutely I think they're one and the same. We have to get more we need to be more environmentally friendly. We need to use the power appropriately, and so absolutely it will be more sustainable going forward.
Perfect. Samuel?
Well, I think the tech itself not, but I think the ecosystem has to be, every player has to be more cognizant of it and push it on their own. But it also has to be an active exchange with legislation as much. There has to be a much more coherent understanding of the aspects that it entails. And then at the end, it's also something of geostrategy to say, okay, how do we want to utilize this continental Europe and whole of Europe as such, and really drive it together. And then it's about communication, it's about talking, exchanging, and driving those conversations from private, public sector and legislation to have a really coherent view and see also what value it brings to society. And from there on, yes, drive the sustainability topics even more, in that it also makes sense and that stakeholders see the value as much in it and just not a threat or a blockage in terms of expanding. So it's a multi-layered discussion and highly interdisciplinary thing to bring many parties together to have a public discussion, a coherent discussion, and understanding of different viewpoints from operators, suppliers, and legislation and public opinion. I think it is a chance to make it more sustainable, but it just won't happen on its own.
Last but not least, Jonathan.
Yeah, I think both Giuseppe and Sam have really hit the points on this one really well. I think just to add to this, I think we are going to see more and more AI. We're going to see more and more sites coming through to it. Yes, we're going to have to be more green in our thinking, and I think it's going to be shaping out. What I would say though is that I think up to date, I think we're only starting to scratch AI services over the last couple of years. I think as we start to see more data centers go live, the improvements are going to, and the developments are going to rapidly progress even further. Hopefully that might then mean the fact that we actually create more industries, more businesses, more verticals off the back of that, as those people then can utilize more tools, more services off the back. And also from a green perspective as well, how that then factors through in actually improvements, because the amount of companies I see who are looking at digital twin data, the first thing they do from a green perspective is create a digital twin. 9 times out of 10, they never realize where the data center is lying in the background and how green that data center is and all that data they're then driving that through. I think to Sam's point, we just need to drive up a little bit of education within the world of, like, when companies are talking this great big green talks, we're looking at green power, green solutions coming through, of where this is going to be, or we can all end up a little bit like Elon, who's brilliant, but it was a case of whereby we start talking about data centers in space and data centers on the moon, which is going to be, does that navigate that issue, or does that then bring a whole new challenges to it? Probably more the latter, but again, it's just thinking a little bit outside the box. So I think we're in a world now which is rapidly evolving. We've not touched on it as well, but there's also quantum computing coming through, which I touched on very lightly. And that's also going to have a bigger shape out on what we look to do over the next 5-7 years when that starts to come into play. So again, I think it's a case of, yes, it's going to change a lot, but I think we just need to be aware of those changes and just work with them rather than fighting them. So a case of it, I think that's the key thing to learn from here.
Perfect. I fully agree. Well, gentlemen, I think that's all the time we have for today. Honestly, I thank you guys so much for your time and your in-depth conversation that you've had with us today, and I really appreciate it. Thank you so much.
Pleasure.
Thank you.
Thank you.
Thanks, guys.
Thank you so much, guys.